Okay, welcome to the interview preparation guide. We are focusing on search algorithms. This is part 3, focusing only on binary search. So today we'll describe another problem which also shows up pretty often in interviews, and we'll keep the problem. The solution is definitely based on binary search because this problem is included as part of binary search. We'll first describe the problem as usual and then solve it. The problem goes like this. Search a sorted array for the first element which is larger than x. So this is a little bit different from conventional binary search because you're searching not for an element but an element which is greater than an element. Let's see how we can solve it. So definitely the array is sorted, so that's a hint that you can use binary search. So it's actually a fairly simple problem to solve. You can do the following. You can search for x in array using binary search. So three things can happen. Three things may happen. One, you found x. If you found x, then move linearly to the element which is greater than x. So you start from the point where you found x and go to the next element which is greater than x and return the index. Otherwise, you didn't find x. That's another scenario. You didn't find x and stopped at an index such that a of that index is greater than x. You are done because you got the first element. You are done because you got the first element which is greater than x. The third is you did not find x and stopped at the value less than x. Then you scan forward linearly till you find the first value greater than x. And that solves the problem. Now, one key thing is, what is the complexity of the algorithm? Complexity. Now, binary search is order of log n. However, the worst case complexity runtime is equal to order of n. Why? Because in the worst case, you may have to scan the entire array searching for the element which is greater than x. Think of an array like this. The last element is x plus 1. So this is a worst case scenario. So this was a fairly simple problem. We showed the application of binary search in this case. However, one key tricky part is the complexity of the algorithm. The complexity of the algorithm is not log n but order of n, because you have to search for an element which is greater than x in this case. So even though you can search for x in binary fashion using order of log n complexity, but once you stop there, from there to the element that is greater than x, finding that part is a linear search. So the complexity of the algorithm is order of n. Okay, we're done today. We'll get back to another binary search based interview problem in our next session. Good day.